Hello and welcome to our introductory webinar Condition Monitoring Based Vibrations. Here you will learn why condition monitoring is important in power plants and industries and why it's not a luxury anymore. Our speaker at the glance is Thorsten Wetzel, Head of Omnivice Availability with more than 10 years of experience in the energy sector and 7 years in the strategy consulting.
Today we will talk about vibration problems and how unexpected and expensive machinery failures based on vibrations can be. Afterwards, we will talk a bit about the different types of maintenance and what solutions are today available to fulfill the maintenance task. And then we will talk about um, condition-based maintenance for vibration and the benefits which are coming with tools used for condition monitoring. And afterwards, I would love to show you a little bit about our offerings. So let's start directly with the different vibrations problems we currently know. So the worst of it worst is, of course, when people get hurt because of the vibration of rotating equipment. So this is what we want to avoid everybody. So the second thing is, and this is usually seen on a daily perspective, is when we get quality issues of the products we want to produce with our machinery by vibration issues. So if it's tuning, drilling, milling, so on each kind of process, we see that vibration will have a negative impact. So, and last but not least, we see also an impact on the machine behavior when the vibration leads to a failure. And so when we see wear and we see degradation of the material, this is definitely the third big issue of vibration problems. So let us talk now about the unexpected and expensive machinery failures which come out of vibration issues. So, of course, and the most obvious is that machinery failures lead to unplanned downtimes, so machines are not available. Health and safety issues we already discussed. And of course, environmental risk and consequential failures like collateral damage on other equipment can be the failure. So what we see on our customers is that with really bad vibration issues, they are losing up to 5% of their yearly production capacity. Or we see on other customers that they have an increased maintenance and repair cost budget of more than 50%, just because they couldn't predict perfectly their vibration issues. So this leads us that we actually need a different maintenance strategy to avoid this extra cost or this capacity losses. So important for us is that currently in the industries we are using time-based maintenance. So we are exchanging certain parts of the machine after a certain period of time, or we are doing services after a certain operating hours which are conducted on the machine or which were produced with the machine. So the problem is that only 15% of the machines on average really can be predict the wide wear out zone patterns of the machine. So we usually are changing material much too early, and so that means that there is additional cost by replacing spare parts which are actually completely perfect. On the other end, that more than 80% of the machines, of mainly rotating machines, they have no really predictable window where the equipment should be under service and should replace certain spare parts. And in this case, it needs a totally different strategy. Let's talk now about the different types of maintenance. So the most common maintenance forms are probably 1 and 2. So reactive maintenance, what is a run to failure, where we are waiting until an item breaks and then we repair it. or preventive maintenance, what I already have described on the slide before, where we have a time base, and after a certain period of time, service activities or maintenance activities will be done, or after a certain number of operating hours, the same services are then conducted. Now, the more sophisticated maintenance strategies are, of course, predictive maintenance and prescriptive. So predictive means we are looking with data at the current condition of the part or of the asset, and with this we are putting conclusions together when is the right moment for the right maintenance task. And with prescriptive, we are even looking in the future to prescribe on a trend reliability base the different maintenance strategy and find the optimum point of a maintenance task. So in the past, as we did a lot of run to failure or reactive maintenance, of course, this was expensive. Not only because we couldn't plan quite good when to do the maintenance task, it also caused a lot of collateral damage. So not only the spare part broke or the required asset broke, there were also on the side connective other parts which were damaged. So after a while, so roughly a decade ago, we switched a lot into the time-based maintenance, where we, of course, as I described before, did a lot of run to failure. But for the most critical asset, we also did the repair before something happened. Still, as I described before, we also exchanged a lot of actually quite perfect parts in a machine, but we could here avoid at least the availability losses. So where we are now with all the data available and with the new possibilities on the IT and OT world, we of course have the opportunity to look into the condition. And mainly on the critical assets, this is what we currently do, the critical assets for each process. We are looking what is the quite current situation on the asset health, and with that we are predicting also when is the right moment to exchange it, and this gives us the opportunity to plan better based on data, maintenance activities, and also order spare parts and so on. So in the future, we are not there yet. You see this. This will actually be probably a topic for the next decade, when we are looking more into prescriptive, where we are trying to describe much more the reliability of a plant and prescribe much more in which direction the asset maybe will run. And with this more AI-based focus, we will then be able to do more. We are not there yet. This is why we identified right now the sweet spot in the part of the condition-based maintenance. So what is now available in the market for the different maintenance strategies? So of course we have condition monitoring solutions. So condition monitoring solution, as described before, they allow to collect on a scheduled way data and evaluate the changes, so find the anomalies, so that the different conditions and the health of a system can be evaluated. And of course, the result of this is that we are capable of doing a better planning of the maintenance task. So concretely, it means we can order spare parts in time. We can take care that the people, they are on site when it's required, but also not too long, so that we are only paying for service personnel as it is required. So a condition monitoring solution, which is available currently in the market, uses actually the equipment which is already on site. So when we take a power plant, we already have a lot of instrumentation available, coming with the DCS or with the local equipment installed on balance of plant assets. So we are measuring speed, there are temperature measurements, position, and also vibration and expansion. So in a power plant, more than 100,000 samples per second are measured and are collected. So now it is the task of the condition monitoring solution uh, to connect all this data, and of course the data need to be readable and need to be interpretable. And here comes the point where condition monitoring needs to pre-process the data and then also provide the right charts. So, and therefore it's important to find for each problem and for each issue and for each asset and asset type the right condition monitoring solution. So we mainly see two types of benefits related to a condition monitoring solution. On the one hand side, of course, the improvement of the performance. So as you see on number one, the avoided downtime leads directly to more availability and to more production outcome. But also we are maximizing capacity and improve the production, since we are looking not only for when a part needs to be exchanged, we're also looking when is the right moment to do some service to improve the capability of each of the parts. On the other hand, we are looking for reduced OPEX as the second paragraph for benefits. So we eliminate unnecessary operation and maintenance work. So we are using spare parts or parts as long as they can be used. And on the other side, we are also doing only the work which is required. So this is definitely a benefit in cost of labor and cost of material. So what does it mean in numbers? So we did with our customers evaluations, what happened after they installed and implemented the process of condition monitoring. We found actually four pillars. On the one hand side, they of course improved their availability. So that means they reduced their work on repairs and also on replacements. On the second pillar, and it's the biggest, is they improve their availability. A lower amount of unforced outages, and as well in better use of the available capacity by changing spare parts in time. On the third pillar, they improve their cost by reducing maintenance tasks. You know, with the condition monitoring, it's also possible to do a lot of the evaluations automatically, and they were capable of reducing also costs by using their diagnostician experts on more units. So they improve, for example, the number of units covered by one expert from 1 to 4. Instead of one powertrain to be analyzed, they could do at the same time 4. So overall, we are talking about almost 400,000 on average over the different studies, 400,000 euro on benefit on an annual basis, and then we are taking a 5-year period where a condition monitoring system is at least to be used, and it's a benefit of 2 million. What is in comparison to the investment which is required to install it, and the amount of resources to be that it's be used, definitely a big gain. So what does Siemens Energy offer for condition monitoring? Let's take this brief journey through our portfolio on this point. So Siemens Energy offers with the OmniWise D3000 portfolio its own condition monitoring solution based on our hardware, our WIP3000 machinery protection system. We are applying our VibraExpert CM500 as a state-of-the-art condition monitoring solution, which allows our customers to do root cause analysis and condition monitoring on state-of-the-art functionality. So let's spend a couple of words on the WIP3000 machinery protection system. So we have a state-of-the-art redundant system, so which can be applied in all industries which require redundancy. We have a simple spare part concept, which is only one I/O card per rack, or one type of I/O card per rack, so there is no handling of different spare parts required. Of course, it's part of the Omnivice family, so there is a direct connection to our T3000 system and the visualization possible. And we are sensor agnostic, so our system can be connected to all kinds of industrial standard sensors and does not need to be come with its own sensor. So, talking about the condition monitoring solution, so we have different kinds of tools available, from simple trending and X and Y tables. We go up to a transient recorder. We have a frequency monitoring for balance of plant assets. So all kinds of features are available. You can check this out also on our webpage, or you reach out to us. Our Omnivice D3000 products are globally available. We have so far executed more than 1,000 projects in over 75 countries. And of course, we're interested also to see where else we can help our customers or our future customers with the condition monitoring solution.